So turn the page. If you like to highlight stuff, you can highlight the definition of a trig identity. So what a trig identity is just an equation that's always true. And like I said, from our big ideas in our first unit, we know a couple already. Sine squared plus cos squared is always equal to 1. Tan is always equal to sine over cosine. So those are two big ideas that we have already. Some of the other big ideas, well, they're not big ideas, but other trig identities that we already know are our reciprocal identities. You know the definition of cosecant. It's 1 over sine. You know secant is 1 over cos. You know cotangent is 1 over tan. If you wanted to, you could also write these ones. You could say sine is 1 over cosecant. Cos is 1 over, 1 over secant. And cotangent or tangent is 1 over cotangent. Again, it has these ones. We know that tan is sine over cos. You also know that cotangent is cos over sine. These are going to be our tools. So I'm going to hand out a sheet where we're going to do some preliminary practice with identities. We're going to do some of them together, and then we're going to work on them. So let's look at the first one, number 5. A couple of things. With these identities, they'll always start with the word prove. So they want you to prove the following is true. And the first one starts off with cos t times secant t equals 1. This is what we want to prove. So when you're trying to prove something, you can't use what you're trying to prove it's true. Does that make sense? So we're not allowed to think of this as an equation. We're allowed, so the first thing we're going to do in all of our proofs is draw a line at the equals sign that separates the left side from the right side. And it becomes a puzzle. It becomes a puzzle because what you want to do is you want to change things on one side or on both sides until eventually both sides look exactly the same. Currently, they don't look the same. We've got a 1 on one side. We've got a cos t and a secant t on the other side. But if we're changing things, what could I change secant t to? I could change secant t to 1 over cos t. At this point, now I'm multiplying. I could think of cos t as cos t over 1. How do I multiply fractions? Is there anything I could simplify? You can multiply the top, multiply the bottom, right? And do you notice that these could simplify? And so this is equal to 1, and we've solved the puzzle. We made the left side equal to the right side. So we write out the equation, we draw a line to separate the left side from the right side, and then we use our skills with the toolbox that we have, which is our reciprocal functions, our big ideas. Tan is sine over cos, cotangent's cos over sine, and manipulate it until we get the sides to equal. Once we've done that, so now 1 is equal to 1, we write a final little statement to say that we are finished. Do you know what those 3 dots mean? Therefore, you know, there's 3. Okay, that was bad. Yeah, therefore, the left side equals the right side. Well, you want to say that you've got your left side and your right side of your original 1 done. Okay? And then we can add some fancy end of proof math stuff. This is just for fun. But you know what? When you solve these, some of them are going to be hard. You're going to be so excited. You're going to want to add some extra special stuff at the end. So many math proofs, when they're done, add this at the end. It is an abbreviation for something in Latin. So really important stuff to know. It is quod erat demonstrandum. Okay? Which loosely translated means what you asked me to show, I showed it. What was asked for was demonstrated. Quod erat demonstrandum. And then me personally, and this is probably from when I was in university, the textbooks that I had, all of the mathematical proofs after doing the QED, they had a little box that had some fancy shading. So I always I take my time, and this is my special thing that I end my proofs with. Okay? You can create your own, like if you have something you want, like you want to do, you know, a sideways hashtag or something, you can make up your own little symbol. Don't make it too complicated that it takes you half an hour every time you finish a proof. It can be a smiley face.
Yes.
No. Yeah. So I have that at the end of my proof to say that we've completed it. So there's our first one. We're going to do a little bit more complicated one next. Let's do number 12. No, we are not even close to ready to getting into the ones in the 40s. Like those take some, you have to do some trig push-ups to train before you can even get close to the 40s. You'll get there, but yeah.
She's like, just go get it.
Number 12. So this number 12, it starts with secant theta over cosecant theta equals tan of theta. So we write out the question, we draw our line to separate both sides. And in number 12, I'm going to introduce to you a very famous strategy. If you think of all 6 trig functions, sine, cos, tan, secant, cosecant, cotangent, in our toolbox, can you see that no matter which one of those you pick, you could change it into something that involved only sine or cosine? So for example, what could I change secant to if I wanted to have something only sine or cosine? 1 over cos. So I'll do that. Oh, next thing I want, before you write this, I want to make sure, leave a little space in between here. Because you are going to write so many fractions and fractions inside of fractions that if you don't space things out, it's just going to all blur together. And you might pull information that was from the previous line accidentally into your new one, and they'll throw everything off. So being organized, a little bit of space there. Again, if secant's 1 over cos, what's cosecant?
1 over sine.
1 over sine. Notice how I used a big, thicker line here to show my main dividing, and then had my little fractions on the top and the bottom? Okay. And then I'm going to do a little bit of space here again, because this is the one big thing. And with identities, what you're looking at is this equal to what I wrote below it. And then I need to write something equal to this. Well, what could I do with this? Again, we want to simplify 90 to 95% of these proofs can be done just by thinking, can I get a single fraction on both sides with sine and cos? This isn't a single fraction yet. So what do I need to do with this? Multiply by the reciprocal. And now, if I multiply the top and the bottom, I get sine theta over cos theta. Can you see on this side, on the right side, can I change tan to just sine and cos? It's equal to sine over cosine. And by changing both to sine and cos and getting a single fraction on both sides, they're done. They're the same. So you get to do the fun little part at the end. The left side is equal to the right side. QED. Oh, yeah. Oh, feels good. No, I'm all out. So this is the format. We can never move things from one side of the equation over to the other side, because that would be using what we're trying to prove is true before we've proven it. So you draw the line to say, I'm only allowed to work only on the left side by itself, only on the right side by itself. A main strategy I introduced to you is that you can change things to sine and cos and then get things as a single fraction, and 90% of the time that will be enough to get things to be the same. Sometimes there's other methods to use in there. Look for them, because sometimes they can be shorter. But for right now, we're going to take some time to start the rest of these. You should be able to do up to 24.
How many years you got?